Thanks for having me along, and welcome to a little session on Logic Apps, just having a chat about what it is and how I use it, kind of where it fits. It's certainly been an interesting time recently in terms of trying to orchestrate anything in Azure. It's a challenging thing, because it used to be really easy. Life used to be so straightforward when we had a single box, and we had SQL Server on that box, and we had SSIS and SSRS and all those kind of things on there controlling it. And orchestration was just simply a case of, I'm going to make an SSIS package and tell it to do things. And there's a whole transformation that's obviously sort of comes along with using the cloud. The cloud is, we're talking about distributed components. We're talking about a whole range of different tools working together to do what we're trying to achieve. So you can no longer have just this single one method of orchestration. You need something that can pull all these different disparate components together. And that's kind of Logic Apps. Logic Apps is a way of orchestrating across a whole world of different components to try and give some kind of cohesion to it. However, it's not the only choice. So we have DataFactory as well. DataFactory is quite well known and has been going under its own butterfly-like transformation recently. So we'll have a bit of a chat about how the two work together. Do you need one if you're using the other? I guess kind of, where the differences between them lie. So as Mark said, I'm the Chief Cloud Architect for a company called Adatis, and we do Azure analytics of all kinds. So we do a bit of data science, we do some data lake stuff, we do a lot of classic Kimball style models in things like Azure SQL Data Warehouse. We use a range of these different tools, and the challenges are the same across it. How do you tie these things together? So the main question is it SSIS in Azure? Now that question is kind of moot now that we do have SSIS in Azure, and the answer is obviously no, it's not. But it's close. It does some similar things. It has that kind of similar role. So SSIS, if you're used to it, has two aspects to it. It's got the data flow, picking up data, doing heavy data transformation, data cleaning, quality, validation, merging data sets together, all that kind of thing. And it has the control flow, I want you to talk to that thing, make a decision, get a parameter back, go different routes based on the results of that parameter. So it's better if you think about it as those two separate things. You've got control flow, you've got data flow, and Logic Apps does a similar thing to the control flow. That idea of here's a sequence of events that might be done by different servers, different systems, and I want you to go in order and poke them and make decisions and do if loops. And Logic Apps has that kind of role. So no, it's not exactly the same as SSIS in the cloud. It's different, but it's very important. So that's who I am, blah, blah, blah. We've heard all that. So what we're going to have a chat through is why we're here, what are Logic Apps and why do we need them. A little bit of terminology, so introducing Logic Apps to you, talking about the different terminology and things, where they came from, why they're there, some of the core concepts, and most importantly, we're going to do a lot of demos. So we're going to set up a Logic App. We're going to show you a couple of live demos. So we're going to do some Twitter semantics, so we can actually sort of go and have a look. So when someone tweets, do some sentiment analysis, say, are they tweeting nice things or nasty things about me? So if anyone on the call is a Twitter lover, you're welcome to try and write nasty things about me. We can see if the sentiment analysis picks it up. But it's so quick and easy to do that we can do those kind of end-to-end demos, and hopefully that'll kind of show you where Logic Apps fits in. And then we'll talk about some design patterns and wider architectures. So based on what we've seen, based on the functionality, where does it fit in modern architectures? Where does it, if you're doing the data kind of things, how does it work? So that's the plan. So if you've got any questions during it, feel free to pop on the chat and I'll see if I can get to it, or we'll have a bit of a question time at the end anyway. So, Cloud BI. Now, this is one of the big things. I mean, I'm talking about Logic Apps from a BI point of view because that's my background. You don't have to use it just for BI. You can use it for pretty much any kind of integration workload. Lots of messaging usages, lots of kind of control back-end application things. Me, I talk about data, so that's my particular love. So Cloud BI is an interesting thing. It's gone through several different iterations. Again, as we were saying, we started off just having that one box, and people jumped in the cloud and said, I'm going to do exactly the same as I've always done. I'm going to have a VM and install SQL Server on it. And then we've gone through some evolutions, and people are now building out disparate modern warehouse things. And a little bit of terminology for people who aren't that familiar with Azure things. We've got some different types of Azure component. So when you're dealing on-prem, so way across on the left, on-prem, everything is your responsibility. So you need to look after the building, the hardware, the networking. You need to make sure it's got aircon. You need to install the operating system. If any bits of the hardware fail, you need to look after replacing it. Essentially, if you buy a server, that's your server. You can look after it. You've then got what we call IaaS. That's infrastructure as a service. That's essentially saying Microsoft can deal with the hardware, they can deal with the physical stuff, they can deal with the networking, but I still want to be able to deal with the operating system, and I'll be able to patch it, I want to manage it, I want to do security, I want to decide what applications I install on that server. So it's kind of like that halfway house. You're renting a server in the cloud, but everything else is your responsibility. If that server breaks, that is your problem. And for me, that's as the whole point of my job is to deliver analytics value to the business. If I'm managing a server, I'm not doing that. So IaaS for me is no good. I don't want to have a server. I don't want to have to install things. I want the next step up, and that's PaaS. So that's platform as a service. And that's essentially, you're getting the benefits of the application. You're getting a SQL server, and you can log into the SQL server and type SQL and do all that, but you don't have to worry about who's installed it and patching it and backups and all that kind of thing. So PaaS is kind of where everything's going, what we're trying to angle towards. Obviously, on the far end of the scale, you've got SaaS, software as a service. Someone's written the application for you, and you don't even know how it works. But we're developers, we don't do that. So PaaS is our sweet spot. So Logic Apps is a bit of a weird one in that it's known as iPaaS. That's an integration platform as a service, but it does sit in that PaaS line. So what that means is you don't have to do any management of it. So it'll automatically scale out. It automatically looks after its own version controlling. It is a fixed system that you don't have to manage it too heavily. And we'll go and have a look at it, so you'll see what I mean by that. But essentially, it's built for fast development and it's low maintenance. So, as I said, I don't want to manage any other servers, so this is good news for me. So, I've been talking about, the new modern architecture, all these distributed services. So as a quick glance at what I actually mean about that, this is one of our modern architectures currently. So we've got a big old data lake in the middle. We're using things like data lake analytics to process data. We're pushing out to various different things. There's a lot going on in that diagram. There's a whole world of different systems that need managing and need tying together. And then going along the bottom, you can see we've got DataFactory managing these processes. And then that little icon, I don't know if you can see it around the bottom, that is our Logic app. So we've got messages and Logic apps. And so it's all part of the same system. That's what I was saying in terms of it's not do you use DataFactory or do you use Logic apps. For us, they are symbiotic. They are two systems that fit quite nicely together. But again, we'll talk about how that works. So, the kind of data flow, what we're doing, this kind of thing. We've got a lot of data that's landed in the lake. We're picking up, we're doing a job, we're doing some pre-processing. Now I've got data lake analytics here. That could be Databricks now, the new PaaS Spark service. It could be an SSIS package. It could be a ton of different things. Essentially, something starts, processes some data, puts it down again. We've got things like SQL Data Warehouse or a SQL database. Again, we can suck data into it, do lots and lots of stored procs getting that data ready. Got things like streaming analytics, which are landing data on a regular basis. So the whole big data thing is we've got data that's maybe unstructured. Maybe it's coming in too fast that we can't really deal with it in traditional methods. Maybe it's just awkward, or maybe there's just too much of it. So we need these different sets of tools to manage all the different types of data that we have in the modern society. And again, we can dump that into Power BI. So why do we have a challenge here? Now, I'll admit the next slide is a little bit out of date because I wrote this session towards the end of last year, and at that point we hadn't had DataFactory v2. So I have some complaints about DataFactory, and some of them have been reconciled, and I'll show you what that looks like. I'll go into what DataFactory's answer to some of these problems are. But again, I still don't think it answers all of the problems it should do. So talking about DataFactory. the problems with DataFactory. So you used to be only able to trigger it on a date slice or wall clock way. So DataFactory itself can be triggered manually. So you can call a REST API and trigger a pipeline, or you can have its built-in triggers, and that's the date slice, and that's so you can say this factory should activate every hour, every day. It's a tumbling window style of things. So that's kind of cutting your data up into regular time-based chunks, and it'll just run on that cadence. Wall clock is, I'm going to trigger 2 o'clock every day, noon every day, that kind of thing. And that's all of our options to DataFactory. And that's not reactive enough for me. You know, maybe I'm being sent a file by a third party, and I don't know when I'm going to get that file, but I want to process that file as soon as that data lands. Now, with DataFactory, I would have to set DataFactory up to be running every 15 minutes, just constantly trying to do it. Or I have to have something else tell DataFactory to run. So DataFactory can't go and watch events itself. Okay, you've got limited flexibility and compatibility. You know, you can't actually get out there and connect to lots of different things. You can't tell DataFactory to connect to things like Twitter and SharePoint, and there's lots of different interesting things that you can't go. You know, there's a limited subset of things that DataFactory can go and reach into and pull data out of. Code-based designer is no longer true. We now have a nice GUI for it, and I'll show you that. But yeah, anything that's kind of really awkward in DataFactory, you end up writing C#. Now that used to be as DataFactory custom activities. It's now probably as Azure functions, but even so, you reach a point where you have to then start hacking code, and that's not great. You know, I want more flexibility. The kind of things that we were trying to do with DataFactory and really struggling is the kind of the old school SSIS style. You might call a store procedure, bring that in. I might make a decision based on the results of that proc. So that proc gives me a result. If that result is, I didn't do anything, there's no records to process, then I'd log that and I'd finish. Otherwise, if it brings some records back, I'll do a for each loop, I'll do some processing, I'll log a result. Essentially, I want a flexible dynamic system that will make decisions based on the results of earlier actions. I want to be able to build an actual intelligent workflow that's working through these things and actually managing it properly. So on conditional paths, I want failure paths, I want for each loops and scope containers, and I want ad hoc executions. Now again, DataFactory has provided some of these bits of functionality. You can now do a for each loop, for example. You've got failure paths, but they're a little bit clunky. They're a little bit locked inside the DataFactory kind of workflow. It can't deal with complex JSON, for example. You know, so if you call a web service and that web service brings back a JSON payload, DataFactory is not great at understanding that. You need to pass that off to something else to parse it and then return results. So it's getting better, it's getting closer, but it's still not the full story. And that is why we need logic apps. That's what logic apps is for me. It's a level above DataFactory. It's a very lightweight orchestration system that can be triggered by events and can do things like talk to a web service, get JSON back and understand that JSON. It can talk to a much wider array of services, including ones that are much more in your Office 365 style. You know, so it can talk to Twitter, and it can talk to Facebook, it can talk to loads of different modern technologies. It's much more open, broad brush orchestration service. So where did it actually come from? It's actually a weird love child of BizTalk server and integration services in my eyes. So it does that kind of BizTalk style thing of you can take a message coming from one thing, you can tell it how to interpret, how to translate between different messages. Essentially, you can use it as an enterprise message bus if you really want to. There's I guess kind of a full professional mode to Logic Apps, which is a lot more like traditional BizTalk. But the lightweight version of it is so much more than that. It's so much more flexible. It's so much more open. So don't be put off if you're historical, not a fan of BizTalk. So the different bits and pieces that we've got in here, it's worth knowing that there's a thing called Microsoft Flow. So if you've heard of Flow, that is pretty much the same as Logic Apps. It's the Office 365 version of Logic Apps. It's slightly cut down in functionality to not scare those Office 365 people, because apparently we need to do things like that. And it is a little bit like if this then that. So you're saying something happens, do something. So if I get a tweet, write it to a database. If someone opens a SharePoint doc, write it to a log. If I do something else. So that's Flow. So Flow is your lightweight version of Logic Apps that's for Office 365. You've got Logic Apps itself, which is much more fully featured, and that is within the Azure Portal. So you can use Flow if you just have an Office 365 account and you don't have an Azure subscription. If you do have an Azure subscription, I'll use Logic Apps instead because it's more fully featured. It's got everything in there, and that's just got more functionality. And that is your either using it as a BizTalk translation engine, or it's a control flow orchestration scheduler. And then finally, there's Logic App's dark brother, which is Azure Functions. Now, Azure Functions are very, very similar to Logic Apps, except it's all code. So if you want when something happens, a bit of script to run. So, so you've got a little bit of C#, a little bit of PowerShell or Java, and you want, when someone does this, run this thing, you can use functions for that. And functions are really useful for extending Logic Apps. So Logic Apps has a ton of actions out of the box, but if you want to actually then write your own action that happens, you can use a function to do that. So they are a little bit like SSIS script components in that way. So if you're using an SSIS control flow and you're using the out-of-the-box things, and then you want to do an action that you don't have an out-of-the-box task for, you then write an SSIS script component, put your C# in there. You can use functions in the same way. They integrate really nicely to Logic Apps, so you can use Logic Apps to have that nice graphical design surface and then push it out to a function when you need to do something that's a little bit more complicated. So Logic Apps functions, two really, really great tools to have in your tool belt if you're building this kind of distributed system. Okay, so range of the different things that we can do, just as some examples. So say I want to connect to Azure Functions, or I want to do an FTP, blob storage, SharePoint, I want to have event hubs, Twitter, Outlook, loads of different things that it can connect to. And the kind of things that we're doing is saying, if someone tweets with a certain hashtag, log it to SQL Server. So you can do that nice little workflow. If someone modifies a file in SharePoint, email the library owner. And you can have those just quick one-step reactionary things, or you can build up some things that are a little bit more dynamic. So I could say, when my home server is unresponsive because my email's gone down again, I can then send a complaint to Virgin Media. I can send a complaint email. I can then log a support request. You can basically automate your life by building up these little workflows. And that's what Logic Apps is for. So if you get that, that is the whole point of Logic Apps. Something happens, here's what to do afterwards. It's building out a load of little small reactionary elements, and you can chain them all up. So you can have one Logic App, do something, make a decision, fire off, call the next Logic App. It's a way of having lots of little distributed bits of decision making, business logic. Okay, so some terminology. So all those different things that we're connecting to, be it Twitter or Outlook or SharePoint or SQL Server, blob storage, they're all known as connectors. So a connector is essentially the service that you're connecting to. There's a load of pre-built ones. And essentially you're picking which connectors you use in different scenarios. Then you've got two different things. You've got a trigger. So a trigger is an event that will start your Logic App. So that could be someone's inserted the record into SQL Server. Someone's dropped a file into blob storage. I've received a message in a service bus queue. These are things that will kick off your Logic App. And these all have a little payload of information as well. So if someone's dropped a file into blob storage and that's my trigger, it's not just that starts it. I also get told what file it was, where it was, what the file name is, who modified it, the date. You have a load of attributes that surround the events that trigger these things. So super, super useful. And then actions, they're the things that we do as a response. So if someone's, inserted the record and that triggered my Logic App, I can then write that record to somewhere else. I can write it into a log. I can send someone an email. These are things that I am doing. The actions I want to do in order to deal with whatever the trigger happened. Finally, you've got a thing called the integrations, and that's the more BizTalk side of things. And that's when you can give schemas saying, so when this message fires, translate it into this other schema and send it over. And that's more for building your service bus integration side of things. And we're not going to go too heavily into that. That is several days worth of session all on its own. Okay, cool. And I know this is just a load of terminology and stuff that isn't that meaningful, and we'll get to the demos pretty soon. Okay, so one really, really important thing that I cannot stress enough is that logic apps are not for doing huge amounts of data work. So they are meant for sending small payloads of information. It's like event-sized things. So if you ever get to the point when you're trying to bring down, sort of several gigs worth of data, you shouldn't be using a logic app to do it. Logic app should know that the gig worth of data is available and then kick off a service, a different thing, a DataFactory, that will then do the heavy lifting. So logic apps will fall over if you try and do too much. The big thing is, so that they scale out but not up. So you can't have one logic app just doing more and more and more and more work, because they are on deliberately very, very small, tiny kind of VMs. But they can scale out. So one logic app cannot do a huge amount of work, but you can be firing a logic app every, minute, 10 minutes, and then suddenly start sending hundreds, and it will just scale up. You don't need to manage that. You don't have a slider to say, expect it to get heavier. It will just naturally scale. So you're always paying by execution. So it's not like a lot of the more traditional services where you need to decide how big a server you want, and you scale up that server and you pay for that server all the time. Logic apps, if you don't use your logic app at all in that month, you don't pay for it. If you use it a lot and you get like hundreds of thousands of pings on it, you pay more for it. So it's very much a pay-as-you-go, lightweight, self-managing system. And the way I kind of describe that style of don't use it for heavy lifting is kind of, would you put 100 meg of data in an SSIS variable when you're using it? It's all the transfer of information between different actions is that it's in a variable, and those variables you just wouldn't put hundreds and hundreds, thousands of rows of data in there. It's meant for workflow management stuff. Okay, cool. So this is when we actually go and take a look at logic apps. So we'll go into the portal. We'll work through a pretty straightforward example. And then when we've worked through that, I've got a couple more interesting feature examples to show you. And then after that, I can quickly show you ADF and say, well, look, how does DataFactory differ? What are the new bits of DataFactory that do that? And then we'll carry on. So let's just switch over. Okay. This might not be very big, so I'll try and zoom it where I can. So if Mark, you can dip in. If it's ever not visible, just give me a poke and I will sort it out. So, logic apps. So we're going to create a new one. So I've got logic apps down here. And I'm just going to add, oops, don't want to use that customer production, that'll go badly. Just going to add a new logic app. Okay, so I'm going to call it, let's call it hybrid VC. Why not? I'm going to put it in my own one. That makes a lot of sense. I'm going to create a new one called hybrid. Again, just to make sure you guys can see that properly. And I can put it in the UK now. That's all the information I need. Again, because we're not having to pick scale, we're not having to decide how big it is. It's very, very simple what we're doing here. So I'm going to create my logic app. I'll take a moment, go through, just create a blank canvas logic app for me. Just going to give that a minute. And because it's not really doing anything here, these are very, very quick to provision. There we go. So it's already provisioned. I've got hybrid VC is my new logic app ready to go. And that's my blank canvas ready to be worked with. So I'm going to click into it. And because it's empty, it's automatically going to switch me to the designer. So building logic apps is 100% in browser, which is very strange to get used to. So you can do it through Visual Studio, but the Visual Studio Designer just opens this same web page, which is quite strange. So we've got a few things that it's suggesting. So a few different common triggers you can see. So I want to do a trigger when a tweet is posted, when an event grid event occurs. There's lots of different templated logic apps I can just pick up. But we're going to start with a blank one. So I'm going to click on blank logic app. And then this is my logic app design surface. So again, it's fully within the portal. I've got a list of connectors at the top. So there's all the different services I can do. List of example things I can go and use. So I can go in here and I can search for SQL Server. I'll take a moment, and then that gives me the connectors that have something to do with SQL Server. I can go in and I can do some stuff with variables, and that has my variable management, and I'll have a load of actions underneath it. But what I want to do here is I want to do a trigger, and we're going to do a Twitter trigger. So I'm going to grab that one, and you can see I've got my available actions. So underneath my Twitter connector, I've got triggers, I've got actions. Actions are the things that I will do in response. So post a tweet, get the number of followers, get a user, all that kind of stuff. Triggers is what I'm using to start my logic app. So when a new tweet is posted, so I'm going to hook it up to my own Twitter account and click sign in. And this is going to save those credentials within my logic app. And they're going to be encrypted within my logic app service, so you can't get at them. But essentially this is now connected as me using my Twitter account, and it'll go in and it'll poll it. So I've got search text. I'm going to say, I'm going to call this, what should we do? Let's call it #hybridVC. And I can give it a polling. So how often do I want it to go and check if there's any more results? So some of the triggers are actual active triggers. And that's things like you can say when someone triggers me as a HTTP request, and it'll just sit there listening, and it'll only fire when it gets a direct HTTP post. This one's where it's saying, how often should it check? It's just going to poll. So this is saying every 3 minutes. I could change it to every day, month. I can have it run every second if I really wanted to. So you can set up an initial frequency. Okay, and that is my trigger done. That is everything I need to do to actually have this set up using my Twitter, firing every time it finds #hybridVC in a tweet. Okay, I'm then going to add an action. So what do we want to do? We talked about doing a sentiment analysis. And that's another area of the Azure Portal. So I'm actually going to quickly get another window open. So what I want to be able to call the cognitive API. I'm going to pass it the tweet context, and then I'm going to go save that somewhere. So I just need to go cognitive services. I should have one already set up. There we go. Okay, so I've got this one is my text analytics API. So if you've not used the cognitive services, they're essentially machine learning AI models that have been wrapped by Microsoft and made available as a web service. So without having to do the whole managing of your data science models, without having to work on any of the model deployment and the training and the retraining and managing model decay, it's very, very simple set of generic web services. So doing sentiment analysis on text is a very generic thing to have to do. So I'm going to nip in here. So I've got my name, I've got my keys, and that's what I'll use in my logic app. So again, my next action, I've got text analytics. That's one of the things that comes up already. I'm going to click on that. And I can do detect sentiment, key phrases, or detect language. So I can do a variety of things via this one web service. I'm going to detect sentiment. So click on that. So it asks for my connection name and my account key. So I'm going to grab that from over there. Pop that in. Got a key. I'll have to cycle those keys after this, showing the world. Okay. And then I can create that as my connection. Okay, so we then want the text to analyze. So at this point, I need to go from my trigger. I need to get whatever the tweet content was. I need to find out from that information from there. Now, the real neat thing is whenever you've got one of these, whenever you've got an action, that action will automatically spit out a set of variables. So if I click in here, I get this extra window pop up. And you can see, so from the when a new tweet is posted, so that was my trigger, you can see all these different variables that have automatically been populated. So without having to do anything, I've already got my username, my tweet text, the name of the user who did it. I can get any attached photos, that kind of thing. So each of your different connectors, each of your different actions or triggers will kick out a different set of these variables. So I'm just going to take tweet text, just put that in, and that's what I need to do that. That is already set up. It knows which web service to call because it's built into it. It's got my connection details. It's going to pass it the tweet text, and it's just going to give me back some more variables which describe that sentiment. So if I go on to a new step, add an action, this time I'm going to pop it into a SQL Server. So I'm going to just record the results, going to write it down. Need to see if I've still got this table set up, so I'll have a look. So within my SQL Server connector, I've got a variety of different actions. I want to insert a row. So I'm going to take my results, write that into my thing. So that is going to be in, I believe it's that one. Okay, so I'm going to go to wdemo, going to go SQL conf, going to pop in my username and credentials. And then there's an interesting button down here. So connect via on-premise data gateway. So Logic Apps shares the same gateway that Power BI uses. And if you've not come across it, the on-premise data gateway allows you to connect to anything within your own corporate domain, within a VNet, within, the bits that you don't normally want to expose to the World Wide Web. The gateway works by actually poking an outbound hole. So it's kind of your gateway server, which is on-premise, is constantly checking out and saying, is there anything for me to do? So it's a constant polling only via an outbound firewall exception. And then when the Logic app runs and says, I need some data, I need to insert a row, I need to do something, that'll put that into a service bus. And the next time the gateway checks, it goes, oh, there's an action. And it'll send the data out. It'll perform the action. So it's a very, very cool way of actually exposing connectivity to on-premise systems without having to poke an inbound firewall to your SQL Server, which no one in their right mind wants to do. So very, very useful that we can do that. I don't need to do that because this is an Azure system. So I'm going to go create to create that connection. And then I should have a tweets table in here. It's going to work out what's there. So I've got tweets. So I pick the table that I want to connect to, and then that's automatically going to talk to that SQL Server and then bring back, I've now got a list of parameters, which are all those different columns. So it's now asking me just to map my various inputs to this data. Now, tweet date I don't have. So I've got this information. I've got the various different things. I know what was texted. I know who texted it. I've got a load of information, but I don't have the date. So what I've actually got in this little dynamic box, I've got dynamic content, and that's the various different variables returned by my different actions. I've also got expressions. Now this allows me to do a whole range of things, and that can be searching through an array for a particular, the first, the last, the middle, the second, whatever. It can be doing some string, things, concatenating things together. It can be doing if statements. I've been having all sorts of different functionality. And right near the bottom, there we go, I've got UTC now as one of my date and time ones. So if I do that, that's just going to generate a timestamp. So I've made up some content. Whenever this runs, it'll do that UTC now, and then that'll include that in my column that gets put in. Got my tweet text, so I'm going to include that. I had that originally. My tweet user, so I know who it was, who is bad-mouthing me on the internet. So I've got username. And then finally score. So that's the one that's been returned by the Detect Sentiment service. So you can see Detect Sentiment's got a score. And you can see I've actually got a lot fewer options in terms of what I can put into this field. So that's because it's realized that that is actually looking for an int. So it's filtered out all of my various different variables based on which ones can actually just natively be put into that field. So I'm going to pop a score into that. And that is it. So that end-to-end is a new service. As soon as I click save, that goes live. And that one I'll just sit there and check. Every 3 minutes, I'll use my Twitter account, look in my feed, do a search based on hashtag hybridVC, any ones it does find. So this will automatically run once for each tweet it finds. It'll put that via Detect Sentiment, get a score back, and write it to a database. Now that as an end-to-end system, something doing an actual, AI sentiment analysis on something like Twitter, that integration used to take ages to build. And that's ready in, 5 minutes, maybe 10 minutes? And having clicked save, that's now deployed. That's in production. That is now actually running properly in my system. So I'll give that a few minutes to run, and I'll go and check out and see if we've had any tweets. One thing to be very aware of is behind the scenes. So underneath this nice, slick user interface, This is just writing JSON for you. So in a similar way to DataFactory, behind the scenes, we've got this code view, and this is just building up lots and lots of JSON. So each of my different things. So I've got my trigger here. So that's looking, it's my Twitter trigger. You can see the connection it's using. You can see various different things it's doing. Got my detect sentiment in there. So you can see that's my insert row into my SQL table. You've got what I've mapped to each of those different fields. Again, so you can, if you want, actually craft this out of JSON by hand if you really, really feel so inclined. But also, if there's a particular thing that you really liked in one logic app, you can actually copy and paste bits of this between it. You can share code. You can source control this and do comparisons. So this actually isn't true Wild West. You can bring this down. You can put it in Git. You can do compares to say what's changed between the two. The only slightly annoying thing is your connections are well held. They're obviously held by the server, so they're encrypted. So the deployment story isn't necessarily particularly neat for logic apps. But then I guess the build is so quick, I kind of counteract some of that stuff. Okay. So just click run on here, and hopefully I've not messed up my SQL Server, which I did last time. And you can see if we've got any actions to run. If not, I'll show you a Blue Peter style one I've made earlier. Don't think we've got any tweets. Oh, there we go. So we've had a tweet come through. There we go. So someone said, enjoying Mr. Sunlight's tweet. So that's generally positive. So I'm hoping this will have nice sentiment. So we go through. We can see it was put in. That's come back with a score of 0.99. So that's very, very positive. So we've successfully detected sentiment. And then we've inserted the row. And this is one of the really cool things. Whenever this executes, you've automatically got this saved. So I can go back and look through the past 100 or so executions, and I will always have this view that tells me the JSON returned by different elements, what the input was, what the output was. You've always got this debug view, so you can go in and explore what's happened with any particular tweet. Or, well, not tweet, logic app. I do them for more than Twitter, don't worry. Or if I go into a more historical one, you can see I've got all my different executions. I've got a failure. So I can go into the failure and say, well, why did this fail? And I can get that same debug view. There we go. Okay, so there's a condition in there. The condition wasn't met. So this one, it was a slightly more fancy one. I was detecting the language, and then I was making decisions based on the language, and I hadn't catered for that one. So it came back and said, I don't know what to do. So you've got this really rich kind of ability to go and debug things and work out exactly what happened, and it's all pretty cool. So some more stuff can get more advanced. So this is another one. Here's one I made earlier. So I've just done this as a really, really simple recurrence. It's going to run every day. I've got some credentials hard-coded. What I'm trying to do is talk to a web service. I'm trying to authenticate with a web service, and that'll bring me back an access token. So I've got this HTTP call. I'm talking to Spotify. I'm asking it for authorization, so I'm passing in my credentials. And that's going to return me a token. And then I can use that token and bring back playlists and do some analytics on, how have my favorite artists changed over time, that kind of stuff. The annoying thing is, obviously because that's a manual web service, because that's not a out-of-the-box action, then that's not actually going to give me variables. It's just going to give me a whole JSON packet, which isn't necessarily that nice to work with. And certainly if you're working with DataFactory, that would be really, really painful to work with. So there we go. So it ran, I passed it in a load of information, and it gave me this. I've got this back as my JSON packet that I got back from it. Now the next step is saying, well, actually, I would like to be able to use access token and token type, like expiry and scope, as elements in a later stage. And this is where, for me, Logic Apps really shines. I'm going to add a new action. And what I can ask for is a parse JSON action. So within data operations, I've got this parse JSON. So I'm going to do that. So I'm going to say, I want to do it. The thing I want to parse is what's the body that's returned from my HTTP request. So whatever that web service sends back to me, just dump that into there. And then schema. This is when I would go around and I'd write curly brackets. This is what to expect. And I can build out how to understand that particular thing. However, the most amazing thing is this use sample payload to generate schema button. It's a little bit of text at the bottom. If I click on that, I can just paste in what I had as the results. Click done, and it's automatically turned that into a JSON class. So that's now a JSON schema it's going to validate against. And then if I do a new step, maybe I'll do my next HTTP call. I'm not going to go through it properly yet. And then if I go in here, I've now got those different JSON attributes available to me. So that's a really, really neat way of being able to integrate with a ton of different things. You can just say, here's a bit of sample JSON. As you're building it, you just do the call. The call doesn't go anywhere. It gives you the JSON back, and you just copy and paste that into your parse JSON, and you can just keep building it up. So it's a very quick, really slick way of actually building interactions with web services up really, really quickly. So the next step of that, so here's what I made earlier. So it's doing that HTTP call, it's getting my credentials. I'm then talking to a playlist. That playlist brings back a load of data, and I'm storing that in blob storage, so I've got a record of that over time. And again, I'm building up what the blob storage name is from variables, from using the date time, writing out all the contents in there. And then I'm actually working, I'm telling it, this is how to understand that stuff. Again, very similar to SSIS, that kind of workflow with for each containers. So for each record that was in my playlist, go through it, record something into a database, look up more details. You can build quite complex decision-making trees in Logic Apps really, really easily. Now, really, really quickly on the flip side, so over in DataFactory land, we've got this new design service, which is an absolute godsend if you've ever used DataFactory before and you're used to hand cranking JSON. And that has this new section, this iteration and conditionals. So you can do things like for each container, you've got if conditions, you've got do, while, until kind of things. But it's not very good at doing things like talking to web services and getting JSON back. It can now actually talk to a web service, which it didn't used to be able to. But it's not very good at parsing that JSON. When you're digging through, when you're looking at the monitor, it's harder to understand what's going into each activity. It's not quite as slick as that Logic Apps view. The if conditions, essentially you have to build out little mini pipelines that are hidden within the designer. So DataFactory is coming up. It's slowly sneaking up to some of the functionality that Logic Apps has, but it doesn't have the speed and flexibility of getting there that quickly. On the flip side, if you've got something that's going to take, 10 minutes, 20 minutes, an hour to run, DataFactory is definitely your friend. DataFactory is for that heavy lifting, long-running kind of workload. And because DataFactory can now be called by a REST API, we use the two of them together really, really frequently. So we have a Logic App that does the triggering. The Logic App is watching blob storage to see if someone's sent us new data, or it's watching a message queue for the next trigger. Logic Apps gets the trigger. It makes a decision. Is this the right kind of file? Should I be executing now? Is something currently running? Then it can call a DataFactory web service. It can say, okay, I've made a decision. You should execute now. So Logic Apps is that nice little middleman that does something's happened. This is what you should do. And DataFactory for me doesn't have that functionality in it yet. So DataFactory we still use a hell of a lot, but for the actual workload management, it doesn't have the decision-making engine in it for me. That's kind of currently where we are. I'm going to nip back to slides just to finish things off. So kind of those three contenders. So you've got Logic Apps, lightweight, decision-making, event-driven and reactive, and super quick to build. DataFactory 2, slightly better. Still, DataFactory is still pay per execute. So each time it runs, you pay, and that's fine for me. That's good. The big difference is you've now got SSIS in the cloud. So you can now hook SSIS up underneath DataFactory, and DataFactory can execute an SSIS package. So all what you used to be able to do in control flows, you can now do in the cloud. However, SSIS is limited in terms of the things it can connect to. You don't have things like Twitter, SharePoint connectors, all that kind of stuff. A lot of those you have to build manually when you're in SSIS. The other point is SSIS you have to pay for when it's turned on, not when you're using it. So for SSIS to work, you need to specify a set of VMs. It can be one big chunky VM, it can be 200 small VMs. You set a cluster of VMs, and then SSIS can only run when they're turned on. And every second that they're turned on, you're paying money for it. And the flip side is SSIS takes 20 minutes to turn on currently. So unlike Logic Apps and DataFactory, where it's like, something's happened, I want to run it and then I want to stop. I only want to pay for the exact executions I'm doing. SSIS is a bit more old school. SSIS is, I know I'm going to be doing some work in 20 minutes. Turn on my SSIS. Stop paying for my SSIS. Run my packages and then remember to turn it off. It requires a lot more management. It's a lot more like traditional IaaS than the other two and how flexible and quick they are. So SSIS does allow you to do some of those control flow things and some of that flexibility, but it has a load of drawbacks in terms of how cloud flexible it is. Okay, so we talked about this architecture earlier, and each of these different things. So the execution of this data lake analytics job, that could be triggered by logic apps, could be triggered by DataFactory, but we can decide to trigger it via logic apps. The running of these separate store procs, logic apps can do that. If we want to wait for the results and then make a decision based on the results, we want something running while it works, then we can do that via DataFactory as well. Again, all of these things, we've got these choices. That's what logic apps is for me. It's choice. It's an extra thing on top of DataFactory, just to give you a load more ability to do stuff. So a little bit about pricing. So you are charged per activity execution. So that means if the very first thing that happens is it makes a decision going, oh, I don't need to run. Nothing, this isn't the right type of file, or there were no tweets that were with the right hashtag, only the first initial thing will charge, then nothing else will. So that price, 0.00019 pounds per activity execution. So each of those actions, each block on my logic app will each charge me that amount each time it runs. But if it doesn't get hit because I've made a decision to stop earlier, then I don't get charged for it. But conversely, if this suddenly went viral and I had thousands and thousands and thousands of hashtag #HiveVCs come up, then I'll pay for it. So there is kind of a bit of a compromise to be made. You are essentially saying, I don't know how much I'm going to pay, but hopefully you're going to pay less than you would if you have it turned on all the time. It's a two-way street. So that kind of thing. If I've got something that runs, there's 5 actions in my logic app. It runs every hour, every minute, every hour, 30 days. You can build up a hell of a lot of executions, but then it's so cheap it doesn't actually cost that much money. So £41 a month for something that runs every minute is actually pretty cheap, depending on how many things you're doing, depending on how complex they are, depending on how often it runs. Okay, so a couple of limitations. There are caps on logic apps. Now, some of those you can get removed if you actually have a business case and you speak nicely to the team. Generally, can I do 100,000 action executions per 5 minutes, which is still a fair amount of things to be running constantly. And this is per logic app. So if you found that you were hitting those concurrency limits, you could always make a choice and say, well, actually, I'm going to partition this. I'm going to have 2 logic apps that are running this and some logic to decide which one gets triggered by which. You can actually sort of, do some intelligent slicing to build this out. HTTP requests have a built-in timer. There's some design patterns, so you can loop and check things and wait for it, but by its nature, it can't get more than 100 meg of data back. Realistically, if it gets more than 50 meg of data back from a HTTP request, it's going to have a hard time. It's going to be a bit flaky. So when you're using logic apps, it should be quite lightweight. It shouldn't be dealing with vast amounts of data. This is not picking up huge data sets. It's passing messages back and forth and making decisions based on workflow style information. And a single workflow, a single logic app can only have 250 actions. If you get to more than 250 actions, you're kind of doing things wrong anyway. And on the note, a little bit of design guidance in terms of how we tend to build things, the approach that we have to it. So quantity over complexity is a massive thing for me. So if you get to the point when your logic app is this huge behemoth that's getting near 250 actions, you can just logically slice that up into several smaller apps. You can have one logic app just trigger a different logic app. You can build it into nice little sections of business data or business logic. And that'll make life so much easier as well if you're constantly kind of chopping and changing things. If you need to edit a bit of business logic, it's far easier if that's just a small component rather than if that is your entire decision tree and orchestration for your entire thing. So we do a lot of loose coupling. So if we have a data process that is say data's landing, and then we pick it up and we do a bit of processing, we maybe clean it, and then we put it back down again. And then we pick it up and we do some validation and we do some master dataing and we put it down again. And then we pick it back up and we turn it into facts and dimensions. We've got 3 different steps. And lots of people traditionally would just make that as one giant orchestration workflow. Just end to end, this is me processing my data. And that, again, that has a lot of problems. If it breaks somewhere in the middle, you have to restart it from the beginning. If you want to change just a tiny bit of the logic, you have to redeploy the entire thing and test all the way through. So we use logic apps as a way of loose coupling these things. So the first action will trigger, it'll do its job, and then it'll send a message just to a queue. And then the next part will be watching that queue, and that'll trigger, as soon as it gets sent through, it'll see there's a message in the queue, and it'll trigger, do its work, send another message. And this just means that we can intercept these different sections of it. We can pause a certain component, and the messages will just load up, and then as soon as we unpause it, it'll just work through the backlog. It just gives you so much more flexibility to be able to pull these different things apart and actually be able to manage these things as separate instances. So I cannot stress enough, loose coupling is the way forward if you're building distributed cloud systems. And finally, functions. So we didn't really touch on functions. I didn't really want to go into it too much. But as it says, functions are awesome. You need to know .NET. You need to know how to write a little bit of C#. We're actually got a little bit of extra time, so I can show you a really basic function, I think. So let's go in, go to functions. So I've got function apps. So I'm going to create a new function app. So I go in. So there's a few different ways you can work with functions. You can do it properly through Visual Studio and deploy it. You can, a little bit like logic apps, just do it straight through the portal. So again, I'm going to do a HTTP trigger. So I'm going to say, I want to build a new function. I'm going to do it in C#. I'm going to just call it something generic. I'm going to create it. And this is going to go away. It's going to create me a web service automatically. It's going to pre-populate it with a load of code. So there you go. So I've got a little logic app, a little function, sorry. And this is already set up to be expecting to get some data. It's expecting me to give it a parameter called name. And then it's going to say hello name. And even if you don't know that much C#, you can just come in here and just do, hack around a little bit of editing just in the middle of it. All you need to do is just insert business logic here. Change it so it's not expecting name, it's expecting whatever it happens to be, your parameter of choice, your file name, your Twitter text if you want to do something here. A little bit of logic in the middle, and then just tell it what response. So setting up functions is insanely easy, and again, just hit save, and that's then live. That's then a live web service that you can just call automatically, and it'll just pass the results back. And then if we're over in logic apps, if I just grab one of these ones, and I just add a new step. So functions are built in as a connector. So I go to Azure Functions, and then it's automatically found out that I've got a function library. So it knows that I have functions already created, and again, it's given me a list of my functions. So it's even one step beyond it's just giving you a web service and you have to do a HTTP call to it. You don't even have to craft the URL message. You can just say, I want to talk to my brand new Azure function, and then you want to pass what you want to go into the body. Again, so whatever my name wants to be. And then it will just return, and it knows the results to return. So Azure Functions are an incredibly easy way to extend logic apps just with that key functionality. Again, we don't have any more time to run into it, but yeah, I would say if you're trying out anything, then Azure Functions is where your C# should live, generally. So if we're building a new system, if we need an API over something, if we need to do pretty much anything in C#, we'll do as a serverless function these days. Because they work in the same way as logic apps. It is pay-as-you-go. They will scale massively, and they should be super small or lightweight little bits of functionality. So that's another one of the takeaways. Okay, and yeah. So that's all I wanted to run through. So thanks for listening. If you've got any questions, You can tweet me at Mr. Cy Whiteley. Obviously, I will automatically do sentiment on it. If it's not nice, I might not respond. But yeah, no, if there's any questions, happy to answer.
Great, that was brilliant, Simon. Thanks very much for doing that. There are some questions that I've got for you. The first is you did touch on in the presentation the difference between Flow and Logic Apps, but one thing I'm interested in is would there normally be a situation where someone may craft something in Flow and then eventually want to move it into Logic Apps? Is that a scenario that happens?
Yeah. So I've not actually tried to do it. I don't know how easily you can get at the code behind a Flow. I think you're protected from it slightly.
Okay.
Honestly, they are very, very similar. It's just you get a few less options. So when you're searching through the various actions, the various connectors that you have, Flow just has a more simplified list. Other than that, they are very, very similar, and they do work in the same way. It's more the pricing and where it's hosted that is the major difference, really.
Yeah. So you may have answered the next question then. When I recently watched a session on Flow, I was quite annoyed to see that some connectors were premium, and the reason I was annoyed was because Postgres, for instance, was a premium connector, whereas SQL Server wasn't. I guess it's something you'd expect from Microsoft technology. So I noticed looking at Logic App connectors, I can't see any premiums listed there, and I think you may have basically said it's just the execution you're paying for. Is that correct? Or
yeah, so there are actually premium connectors. If I just grab up this page, here we go. So actually there's a slight charge for the actual triggers, and you do have enterprise connectors in there.
Ah, okay.
So there is a differentiation when you're going through these things. I think there is a star against some of the ones in the designer saying this is an enterprise one.
Yeah. Okay, cool. You also mentioned there's You also mentioned there's an analogy with BizTalk. I've used BizTalk a long time ago now in the past, and I remember that we were able to do event tracking or message tracking. I think I may have seen you do something similar with Logic Apps, or it certainly seemed to have quite a lot of logging going on in the background. Is that correct?
Yeah, I mean, so essentially Logic Apps is BizTalk Online, rebranded and made slightly shiny and more, kind of a nicer for people.
Okay, cool.
So yeah, a lot of the functionality built into BizTalk is actually available in Logic Apps. You do get into the more, so you actually just here you've got all this detail for the enterprise version of things. XML maps, XML schemas, all that kind of thing should be fairly familiar if you're a BizTalk kind of guy.
Yeah.
So yeah, no, it should be that kind of thing. Honestly, I don't use it for that kind of stuff.
Sure.
Because I'm a data guy and I just use it for orchestration.
Okay. Do you know if there's any limitation
Yeah,
the amount of history that you can keep from a login perspective? Have you used that at all?
I've not come up against a barrier for it. I think it does automatically archive after a little while, and there's a data retention price, which is fairly low. But I think you do get charged if you have an insane amount of logs in there.
Okay. One thing that really sprung to mind when I was watching your session was the worry about if you're pushing change out. Is there any good way of managing change control for Logic App systems?
No. Realistically. So the Logic Apps themselves, they do version. So if you're in a particular Logic App, like cancel out, you do have a history of the different versions that you've pushed out.
Cool.
So it's kind of like it's really frustrating for me as as an enterprise developer, whereas it's like its own encapsulated source control.
Yeah, yeah.
So yeah, you can go and manage things, and it is kind of it's fairly neat in terms of how it's working, but I want those versions built into my own source control, not each thing lived in its own private source control. Yeah, so we tend to pull this out. We source control the JSON ourselves.
Yeah.
But that's a little bit manual and it's not that slick.
Right. Okay. I mean, that version there looks very similar to syscatalog versions, doesn't it?
Yeah, it's the same kind of thing. Yeah.
Right. So you did give an analogy between SSIS and Logic Apps, and I was just wondering, is there, I don't know whether there's a state for Logic Apps and any transactional states that you need to manage, and is it possible to have transactional blocks?
No, not that I've seen. You'd have to build it manually out of essentially sort of decision logic.
Yeah.
But no, you don't have traditional kind of transaction rollback kind of things in there, no.
Okay, cool. And the final question, so you've demonstrated about connecting to Azure functions. Is it possible to connect to Amazon Lambda at all with Logic Apps?
Ooh. I don't believe that's a connector out of the box. We can have a quick look. But actually, Amazon Lambda is just a web service, so you can just use a HTTP call and point to it. So I'm not sure there's a built-in one. Let's just have a look. No, okay.
Okay.
Just AWS in general. Amazon. There is a full list. I'll ping you over a link afterwards. There is a full list of available connectors. The only one we've got built in for Amazon is Redshift.
Yeah.
But yeah, no, I mean, if I was using Lambda functions, I'd simply just expose the URL and then just do it as a HTTP call. It just means you have to do it manually and you have to pass the results out. But again, that's fairly straightforward.
Okay, fantastic. Okay, I think that covers everything. That's all the questions. I really appreciate you joining me tonight. It's been really, really enlightening, and I'm going to be cracking open my Azure subscription tomorrow, I think. And
I think that's the main thing. It's just so cheap. You
Yeah.
might as well have a go because it costs a couple of p to give it a go and build something. And the Spotify parsing one that tracks artists over time, I built for a friend of mine who needs to kind of track his artists, and it costs, I think, £5 a month just to constantly be kind of polling that every day, keeping track of things, puts it into the most basic of basic SQL servers, and you can build really lightweight things. It doesn't have to be this big enterprise orchestration thing. It's if you're doing a little dabble, you just want to be tracking something, doing something every so often, making decisions, have a go.